Okay. All right. Almost back in action. Yeah, sorry. I had to reboot my entire computer again. I don't know. Maybe I'm just over paranoid or feel like I keep getting scammed. Any which way, back online, back streaming, back to math. So, let's see what we can do with 19 through 27. So we, once again, looking at this, we have 19 through 27 little hints along with it. So when you get to the question, read the question, try the problem, then read the question, try the problem with the hint. And then if you need to, watch what I do, I guess. All right. We're ready to get started, I think so. Let's do it. A particle moves along the y-axis so that the time t greater than 0 and its position is given to us here. Which of the following statements describes the motion of a particle at time equals 1? Well, let's do this because we're doing calculus and we want to know about the velocity. T plus 4. And we want to know about the acceleration. So, what are we doing? And when we plug in 1, so y prime of 1 equals 3 times 1 squared minus 8 times 1 plus 4. So right here we can do 3 plus 4 is 7, so y prime equals 1 squared is 1, 3 times 1 is 3, minus 8 times 1 is 8, plus 4. So that will be a negative 1. So that means it is decreasing. Then we're going to go to y double prime, plug in our 1 as well, and we're going to do 6 times 1, take away 8. And then y double prime at 1 equals negative 2. So that means it is concave down. So if we are decreasing and we are concave down, our graph is going to look something like that. So we are moving down at a decreasing velocity. So we're moving down at a decreasing velocity, moving down at an increasing velocity, moving up at a decreasing velocity, moving down at an increasing velocity. So we are going to particle moving down the y-axis at a decreasing velocity. That would make sense because if we think about this, let's talk about our different tangent lines. So our tangent line here is boom, 0. Then what happens? It becomes negative 1/2. Then it becomes negative 2. Then it becomes negative 5 because we're going to go down 5 to the right 1. You know, like it just keeps increasing and it gets bigger and bigger. So we are going to be moving down at a decreasing velocity is what I am going with. Final answer. Boom. And we could show that the velocity is negative 1. And then v prime, which is acceleration, is negative 2, which is negative. So since the particle is moving with a decrease in velocity, there you go. All right. Let's go to File, Settings, and I want 24 colors, 16 colors. Let's just do 16. Okay. Some variety in my life. Okay. All right. Moving on. let's go to number 20. So integration of f of x equals 8. The integration of g of x equals negative 2. Which of the following cannot be determined from the given information? So can we integrate from 4 to 1 of g of x dx? And the answer is yes. We can make it negative, and then we're going to go from 1 to 4 of g of x d of x. So by flipping, because remember we always want the smallest number on the bottom, largest number on top, and we can do that by making it negative. So we can integrate that, which we know is negative 2. So a negative times a negative 2 is just going to be a positive 2. We can get a solution for that one. Now let's look at this. If we look at, we can take the constant and put it out front of f of x dx, and we can look at that, and we know that the integral from 1 to 4 of f of x dx is going to be 8, and then 3 times 8 is 24. Okay? The last one we're going to have to focus on is integration from 1 to 4, 3 f of x dx, plus the integration 1 to 4 g of x dx. So we can break this up, and then we can put the 3 out in front just like we did and get this one to be 24. And then we can do that and get negative 2 so that our solution is a positive 22. This one we can. When we start to multiply together, that is not, oh, we could do this and then times it by, yeah, that doesn't work. So the only thing we can break up are pluses and minuses with our integration rules, excuse me, and derivative rules, like those types of things. Because remember, when we do the derivative, we could have taken the derivative of the first term plus the derivative of the second term plus however many terms we had. So we can do it individually instead of trying to take the derivative of everything all at once. So yeah, we can do A, B, and D. Which of the following cannot be determined from the given information? We can't do it for C, unfortunately. There we go. Number 21. Oh, okay. So here we go. This one was f of a plus h minus f of a all over h. And what we need to know is the derivative at a. Or just take the derivative of the function. So what we need to do is understand what the function actually is. So we can look at it like this. F of x. And then f of x. So what we want is we want to know what the function is. And if you look at this back one, the sine of 2x. And what they want is the derivative of that, because that's what this limit actually says. That limit is actually trying to tell us to take the derivative of the function. So when we do that, we're going to do the derivative of sine, the outside function first. So we'd always do the outside function first. So then the derivative of sine is cosine of 2x times, and then we talk about the nested function. And the derivative of 2x is just 2. So our final solution comes out to be 2 cosine 2x, which their entitle is giving us letter D. What we do have to pay attention to is when the limit of this, f of x minus f of a over x minus a, that's when we actually have to plug a number in here. If we're just doing h, we don't have a number. That was just kind of our formal solution of taking the derivative of what our function was. So you have to be careful. It's not telling us to plug in a value unless it's f of x minus f of a. Then we're plugging in a specific value. And there you go. Well, okay, number 22. You can see that I had my students actually skip 22 and 23. We haven't gotten there yet. We're going to talk about slope fields, but just on a little getting to know you, getting to know what it's like to be. So we're looking at two functions that look like this. Can't see the choices though. So what is going to kind of make that kind of slope field? Is it going to be x cubed? Well, we know what x cubed looks like. Is it going to be the derivative looks like y cubed? The derivative looks like y squared? Or the derivative looks like x plus y? Without giving too much, think about what values would give you this. Like if we plugged in 0 for x and we plugged in 0.5 for y, what does our derivative look like? So 0 plus, maybe even do 1, and we can get rid of this and see what this looks like. So when we do 0 comma 1 for x and y, what does dy over dx look like? And if we look at this, this is a positive slope. So which one is going to do that? Well, could be all of them. What about 0, negative 1? Which one will give us a positive 1 slope there? And start to narrow down what your solutions actually could be. That's the slight cheat I'm going to talk about. I don't want to go too far into depths, just because my students haven't learned it yet. And their focus is really going to be on these other ones, getting them done. Okay, so a base of a solid is in the region of the first quadrant. So we're talking about the first quadrant. And I know I'm skipping this one as well, but at least start to think about the process. So we're in the first quadrant, bounded by the x-axis and y-axis. Okay, y equals e to the x. So we know our function is an exponential function. Okay, and a vertical line of x equals 1. So now we got two functions going on here. Okay. For this solid, we want the cross-section perpendicular to the x-axis as a square. What is the volume of the solid? So our focus is going to be this right here. And what we're going to do is we're going to revolve that around the y-axis or the axis. Yeah. And x-axis, cross-section perpendicular to the x-axis is a square. Oh, so we're doing that, not revolving it. Okay. Different thing. So what I was trained to do is pull out a slide. Or if I pulled out a slide out of this little shape, this volume that is being made, and we can think about it as there's a front, there's a back, and it's almost like a ramp that it's being made. And then you got this little back thing that's being made back here. And you start to make this little shape or glass shape that's a volume, and what's pulled out, what the front face of it that you see is a square. And then the area of a square is length times width, or side squared. And that is what we want to integrate. We want to integrate the area, and we're bounded by some of these functions that get put into place. Like the side, I don't want to go too much into it. But that's where we're going with that. And we will get there, but we aren't there yet. All right. So here we go. the graph of a piecewise linear function f is shown above. So here's a piecewise linear function. So we have a line here from 4 to 7, and then 7 to 8, and then 8 to 12. Okay? So what we can do is we can, the graph of the piecewise function, what is the value? Oh, so we want to integrate this. So this is the graph of f, and we are looking for the graph of the piecewise linear function f is shown. What is the value of 0 to 12 f prime? So first rule of graphs is know what graph you're looking at. So when we look from 0 to 7, okay? So if we're looking at 0 to 7, just mark 7 here. What is the derivative from 0 to 7? Well, it's going to be the same everywhere because it's a linear function. But what they're looking for is what is the slope of this line. And you could pick a bunch of points, or you could just go down one to the right one, and we would know that that is -1. So from -1 from 0 to 7 is going to be -1, and we can calculate this area in this box fairly easy. Then what we're going to do is we're going to go from 7 to 8 and figure out what this slope is. Well, that's up 3 to the right one, so that's going to be 3. So this rectangle from 7 to 8, okay, and then 8 to 12, we'll finish at 12, we'll see this kind of slope, which is another down one to the right one. So we'll go down to -1 all the way over to 12. Okay, so if I'm looking for areas, I should have area 1, area 2, and area 3. Add these together. So 7 times a -1 is going to be a -7. From 7 to 8, there's only a 1 track in between those. I know 7 and 8, but if we subtract the difference between them, we're just going to get a 1. So the width of this is 1, the height is 3. 1 times 3 becomes 3 is my area for that, for A2. And then A3, we're going from 12 to 8, so that is a 4. And 4 times a -1 again, so that would be a -4. So when we add these together, we got a -7, we got a -4, and we got a +3. So that, at the end of the day, will give us -8. Let's make it a different color. -7 plus 3 minus 4 equals -8. How do we feel about that? And I'm going to tell you I'm about 90%. There we go. Okay, good. I did do it right. Well, I'm curious on, so f of 12 minus f of 0. Oh, because if they integrate it, oh, okay. So they did it a lot easier than I did. Okay, well let's talk about that real quick because that is kind of smart. All right, so when we integrate something, so rules of integration, and think about this: if we were to integrate this function, f prime, we would get back to the function f, and we're integrating it from 0 to 12. So what we would normally do is plug in 12 and subtract 0, and that would give us our solution. So if we look at what is the function at 12, we have negative 4 minus what is the solution at 0. Well, that's a positive 4. We would still get that negative 8 value to begin with. So if we're looking at an AP calculus test and time is not on our side, my way is probably not the quickest way to go about it if we remember what integration really is at the end of the day. We wouldn't lose any points for ours and we would get the same answer, but I do believe that their way is a lot quicker if we understand what integration is in going from f prime up to f. Which if you watch one of the previous videos, I do make like a position, velocity, acceleration kind of chart to kind of explain that. So maybe take a look at one of those. All right. So the equation is here, is a particle solution to which of the following differentiable equations? Okay, so, oh yeah, so this one this one was, I think, very interesting when we had to work it out. So what I need is y prime, which is going to be 2e to the x, because the derivative of e to the x is e to the x, times the chain rule, which will be 6. So, and then the constant falls off, okay? So I'm sitting here with this as my y prime. If I want to talk about y double prime, then I can take the derivative of this. So this right here, y prime, is 12e to the 6x, right? So e to the x is e to the x times the chain rule. So that's y double prime. So then that would be 72 e to the 6x. Okay. So if we think about this, if we can do this, what we should be able to do is take the derivative, which is 12e to the 6x, minus 6 times 2e to the 6x minus 5 minus 30 equals 0. So if we do that, we get 12e to the 6x minus 12e to the 6x plus 30 minus 30, which comes out to be 0, because the positive 30, negative 30 cancel each other out. So this one looks like so far it works. Well, if I double this and I multiply that by 12, this is definitely not going to work. And you're thinking, well, why wouldn't it? Well, think about this. If we were to multiply this by 2, this becomes 24 e to the 6x. And then if we do this minus 12, yes, this becomes negative 24 e to the 6x. But what happens here? We get a negative 12 times a negative 5, which is a positive 60. 60, I hope. And then our final piece is only a plus 5. So this changes. So this changes to just a plus 5. And plus 5. And 60 plus 5 does not give us 0. So that's the game we start to play. And we can do double prime and start doing that game and double prime prime. But I think without wasting my time, I can see that the first one worked, the second one didn't. And it says, is a particular solution the equation? So I don't know if I would spend any more time on that. I would show the first one worked. I would see the second one didn't. Maybe you can think about the double prime quickly. So we're doing 6 times y double prime, right? Minus 5. Oh, we can actually, no, think about it this way. 6 times y prime, because y prime is this, right? And this is y prime times 6. So if we do that, and then we do 5y prime, we can see that right off there, it's not going to cancel each other out. Minus 6y, which doesn't even compute to those because there's only a 2 in front of this and there needs to be a 12 for them to cancel out. So at least you're getting there. Okay, well maybe that will. So let's think about that. So we'll get 12e to the 6x, but what happens? Plus 30 at the end, and we cannot get rid of that number. So ultimately we could have gotten rid of it. We could have gotten 1y prime when I combine these, which is a negative y prime right here, but then we still have that plus 30 at the end. So this one was kind of close. And then that one definitely is not going to work. And I say that because we have 6 y primes, and now we're only subtracting 2 y primes, so we still have a 4 y prime sitting somewhere, and adding that isn't going to do any. That's definitely not going to work. So I believe that it's A. Let us double check and show what did they like. What did they say? Correct. One way to verify that a function is a solution is to check that the function and its derivative satisfy a differential equation. Differential equation involves y and y prime. The correct derivative must be computed algebraically. Yeah, so all they did was plug it in and show that it worked. But okay, yeah, that's the tips they give. All right. What is the value of x at which a minimum value already is telling me that, because this tells me increasing and decreasing, and this tells me max and mins. So I'm already thinking about the first derivative. Okay, so what is the value of x at which a minimum value of this function occurs on the closed down? So here we go. So let's create a number or sign chart, number line, whatever you want to call it. And let's take our function y equals 3x to the 4/3 minus 2x. And let's take the derivative of that. And this is what I was actually talking about earlier. We can take the derivative of each piece and then subtract them at the end of the day, which is where those derivative rules and integration rules, how we can break it up, that's how we're breaking it up, and that's what we're doing. So when we do this, multiply the exponent times the coefficient, so 3 times 4/3, and then x is 4/3 minus 1. So then y prime becomes 4x to the 1/3 minus 2. So our first job is to see if there are any values in between 0 and 1 that could satisfy this to be 0. So we're going to take that 4x to the 1/3 minus 2 and set it equal to 0 and solve it out. So we're going to add 2 equals 4x to the 1/3, and we're going to divide by 4. So that we get 1/2 equals x cubed, 1/3, sorry, the cubed root. And we do actually want to cube both sides so that we can get x by itself. And what that will leave us with is 1/8. So now we have a 1/8. So in between 0 and 1/8, and then 1/8 and 1, hopefully we will see something turn around. And what is the value of x at which the minimum value happens? Well, if this starts high and goes low and then ends high, so if we're going decreasing to increasing, that could play it, but if it goes increasing to decreasing, then both of these are at play for our minimum value. So we really need to know what the direction is. So what we're going to do is we're going to take some number in between 0 and 1/8 and plug it back into our derivative function. So let's keep it easy on us and do 1/27. You're like, holy cow, how is 1/27 going to keep it easy for us? Well, we're doing cube roots though, right? So what is going to be the cubed root of 27? Well, it's going to be 1/3. So we're going to do, let's do it here. Y prime equals 4 times 1/27 to the 1/3 power. And that's going to minus 2. That's going to give us 4. And then that's going to give us 1/3 y prime minus 2. And when we do that, that's going to give us 4/3 take away 2. And we don't need to know what the answer actually is. All we're looking for is the signage. Is it positive or is it negative? Okay, so if we take a -2, we take a -2 and we try and add a positive, it's got to be bigger than 2 in order for us to change that to back to a positive. So this is a negative. So we're going down, and then we want to show that, what can we do? 8/8 doesn't work. Trying to think what is going to work. 8/27. What would be a quick number to figure out? And this is assuming that this is a non-calculator question. My guess is it probably could use a calculator and plug something in. But let's just think about, just for a second, let's go with 7/8, okay? And maybe that will get us where we need to go. So y prime equals 4 times 7/8 to the 1/3 power minus 2. So we will have 4, the cubed root of 7 over 2 minus 2. And then when we do 4 divided by 2, that will give us 2. Oops, can't see that. That will give us 2 square root of 7 minus 2. And there we go. So if we have 2 times even anything, as long as it's not a decimal, and think about the square root of 7. What's the square root of 4? So the square root of 7 is higher than the square root of 4. We know the square root of 4 is 2. So we know this is going to be higher than 1. Because the only thing that would kill us is if the square root of 7 was less than 1, it would shrink that 2 down to something else. And then our -2 would win the game. So then that would be telling us that that is positive. So now we know it's going from negative to positive, and no matter what the endpoints are at 0 and 1, they never are going to be lower than this value right here, which is our 1/8. Boom. All right, let's take a look at what they said though. So they did this, and they found 1/8. The candidates 0, 1/8, and 1, where x equals 0, y equals 0, x equals 1/8, y equals negative 1/16, and then x equals 1, y equals... Okay, so they took the x values, the possible choices of 0, 1, and 1/8, and just plugged those in and found that the minimum value happened at 1/8, because the solution was 0, negative 1/16, and a positive 1, and the most minimal value is negative 1/16. Okay. I'm okay with that too. I guess it's whatever, tickles your fancy and what you want to do to solve the problem. Mine probably, once again, is a little bit longer, but it makes sense to me, so that's kind of how I work it. I have to have it make sense to me. And if this doesn't make sense to you, that's okay. You do you. At the end of the day, you just want to get to the final answer. All right. Related rates. Okay. So, here we go. At time t equals 0, a storage tank is empty and begins filling with water for t greater than 0. The depth of the water of the tank is increasing at a rate. So W of t equals a rate of feet per hour. Which of the following is the best interpretation of f prime of 2 greater than 3? So the first thing we want to do is think about what f prime at t represents. Well, if this is f of t, we want to take the derivative with respect to time, and that starts this game. Per hour, or what happens with acceleration, feet per hour squared. So we're looking at that, and now we're looking at acceleration at 2, which is feet per hour squared at 2. Okay? And then they're saying that this idea all is going to be greater than 3. So, 2 hours after the tank begins filling with water, over the first 2 hours after the tank, 2 hours after the tank begins filling with water, over the first 2 hours. So, think about this. They're looking at 2 hours after the tank begins filling with water, or over 2 hours worth. Over 2 hours worth. This right here should be your indication of what 2 you want to throw away right off the get. Because what is the first rule of derivatives? It's the slope of the tangent at that point. We don't care over 2 hours. Over 2 hours means we're looking at an average or a rate, no, at 2 hours after the tank is being filled with water. So at the end of 2 hours, we're looking at this instantaneous rate of change. And what this instantaneous rate of change is telling us is that we are going to be greater at a rate of 3 feet per hour, which then gets us to letter C, which should hopefully just be using your knowledge base of what derivatives are, what derivatives mean, and not getting so focused on everything. Like I just looked at what W of t is. We don't have a function. We don't have anything else to talk about. So just talk about what W of t is. And then start to break down what is W prime of t. What is that going to tell us? Because we're doing everything with respect to time. And we keep time. And when you think about velocity and acceleration, how does that change? Okay? So keeping that idea in your mind as you go along with the problems as well. All right. So that gets us to 27. We're going to do 28 through, what are we doing? 28 through 36, something like, I don't know. 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 36. Okay. Doesn't seem like that's 9 problems, but it is. We're going to do those tomorrow, and then we're going to do the last 9 on Wednesday. So we're just going to keep this one how it is. If you have any questions, leave them in the comments. And I don't know, keep practicing. We're getting closer and closer. We're almost done. Pretty much have 1 month left until the test. So it's crunch time for us, and we've still got quite a bit to do. So join Discord, join YouTube channel, TikTok, all the good stuff. And feel free to ask any questions you have in the questions tab in Discord. I have the stream going, but when we look at the questions tab, you can ask away on that. I post when I go live. There's that schedule here, Mondays and Wednesdays. The last Wednesday I missed, which is why I'm doing this stream right now today. But 7 to 8 o'clock is private sessions. 8 to 9 is when I go live publicly. All right. If there's nothing else, have a blessed day, and I'll catch you on the flip side.